Good evening students, welcome to Shruti Academy. So those who have not subscribed my channel, please subscribe my channel and also share my videos. So let us start with another topic of chapter 8 of class 10 students. The topic is trigonometric ratios of complementary angles. We have already discussed about the complementary ratios of some specific angles such as 0 degrees, 90 degrees, 45 degrees, 60 degrees and 30 degrees. Now let us understand what are complementary angles and the trigonometric ratios of the complementary angles. Okay, so what do you mean by complementary angles? Two angles are said to be complementary when the sum of two angles is equal to 90 degrees, and the supplementary is the sum of two angles is 180 degrees. So complementary and supplementary are two different terms. Don't get mixed up with them. Okay, so complementary means two angles should have the sum equal to 90 degrees. Now let us take a triangle to be a right angle triangle, right angled at B. Okay, so let us draw a triangle first of all in order to derive the complementary angles, the trigonometric ratios of the complementary angles. Okay, so let us draw the triangle. So this is my triangle, right angles at B. Okay, and A and C are the two angles, the rest of the two angles of the triangle. Okay, so A and C are said to be the complementary angles because the sum of A and C is equal to 90 degrees. Now how it is 90 degrees? Student again asks how they are 90 degrees. Let us see, because the sum of the triangles angles, all the sum of the angles of a triangle is equal to 180 degrees. So angle A plus angle B plus angle C will be equal to 180 degrees. So angle B is already 90 degrees we have taken. So angle C is equals to 180 degrees. So angle A plus angle C will be equal to 180 minus 90 degrees. So that means the sum of angle A plus angle C is equal to 90 degrees. So we concluded that A and C are complementary angles. A and C are complementary angles. Okay. So we need to find out the trigonometric ratios for these complementary angles. So let us first of all, we will take the angle A, then we will be taking the angle C, and we will be finding out normal trigonometric ratios in the terms of lengths, of the triangle. Okay, this sides of the triangle, in the terms of sides of the triangle. Okay, so let us first take angle A. So I am writing over here angle A. I'm writing all the trigonometric ratios for angle A over here. Okay, so we will be getting over here sine angle A. Sine A will be equal to perpendicular upon hypotenuse. Perpendicular is the opposite side, hypotenuse is the side opposite to 90 degrees. Okay, so perpendicular is over here, or is BC. Opposite side to angle A is BC. Okay, so it will be BC upon AC. Okay, then comes cos. Cos A will be equal to base upon hypotenuse. For angle A, base will be AB. So AB upon AC. Then comes tan A. So tan A will be equal to perpendicular upon base. Perpendicular upon base. So perpendicular is BC and base is AB. Okay, then comes cosec. Cosec is the reciprocal of sine. We have already seen. So it will be hypotenuse upon perpendicular. So it will be AC upon BC. Okay, then comes sec. Sec is the reciprocal of cos. So it will be hypotenuse upon base. So it will be coming AC upon AB. It will be coming out to be AC upon AB. Okay, So, and the last trigonometric ratio is cot A. So, cot A. Cot is the reciprocal of tan. Cot is the reciprocal of tan. So, it will be base upon perpendicular. It will be base upon perpendicular. That will be equal to AB upon BC. So, this we have found out for the angle A. Now, we will be finding out for the angle C. First of all, let us see what is coming for the angle C. Then we will be correlating A and C, and we will be getting the complementary ratios. Okay. So, now let us find out for angle C. Okay. So, sin C will be equal to, now we will be taking this angle. Okay, we will be taking this angle. So, for C, my base is BC and perpendicular is AB. Okay, now perpendicular and base changes because the angle C is over here. So, sine is always given by perpendicular upon hypotenuse, or we can say opposite side upon hypotenuse. So, perpendicular is AB upon AC. Okay, it is given by AB upon AC. Okay, sine is given by AB upon AC. Now, next comes cos C. So, cos is base upon hypotenuse. So, base is BC, hypotenuse is AC. Then comes tan. Tan is given by perpendicular upon base. So, perpendicular is AB and base is BC. Okay, then comes cosec, inverse of sine. So, cosec C will be reciprocal of sine C. So, it will be equal to AC upon AB. Then come sec C. So, sec will be reciprocal of cos. It will be reciprocal of cos. So, it will be given by hypotenuse upon base. So, it will be AC upon BC. It will be equal to AC upon BC. Okay. Then comes cot C. So, cot will be equal to reciprocal of tan. It will be equal to reciprocal of tan C. So, it will be equal to base upon perpendicular. So, base for C is BC and perpendicular is AB. So, it will be BC upon AB. Okay. So, we have seen for angle A and C. Now, let us see the relationship between A and C. So, from here we will be getting angle C to be equal to 90 minus angle A. So, in the place of C, I can easily write sine 90 minus angle A. I can easily write sine 90 minus angle A. Let us write down. Okay, let us write down. So, it will be sine 90 minus angle A. Okay, again in the place of C, I will be replacing with 90 minus angle A, because when A will go to that side, then it will go with the negative sign. Okay, so again cos, it will become cos 90 minus angle A. Again tan, it will be 90 minus angle A. So, I am just substituting this angle C to be equal to 90 minus angle A. Okay, then it will be cosec 90 minus angle A, then sec 90 minus angle A, and cot, again last cot 90 minus angle A. Okay, so till here we have done. So, let us mark all these equation to be number 1, equation 1. Okay, let us mark them to be 1. All these to be 1. Okay, and all these ratios to be in equation 2. Okay. Okay, now we have to compare 1 and 2. Now we have to compare 1 and 2. So we'll be writing over here comparing equations 1 and 2. Equations of group 1 and group 2. Now let us see over here, clearly see over here that RHS of sin A is equal to RHS of cos C over here. Okay, RHS of sin A is equal to RHS of cos C. You can clearly see over here. I'll be marking here with a circle. See. This RHS is equal to BC upon AC, and here also this RHS over here is equal to BC upon AC. So we can equate these two. Okay. So we'll be getting over here sin A to be equal to cos 90 minus A to be equal to BC upon AC. BC upon AC. Okay. Now AB upon AC. Clearly we can see cos A is equal to sin 90 minus A, because here RHS is AB upon AC, and that is equal to sin C equal to AB upon AC. So this is also equal. Okay. So this is also equal. So we will be writing over here cos A to be equal to sin 90 minus A to be equal to AB upon AC. Okay. Now BC upon AB. BC upon AB is cot C, which is equal to cot 90 minus A. Okay, this. Okay, so BC upon AB is equal to cot C, which is equal to 90 minus A. So RHS of these two are equal. So we can easily equate tan A to be equal to cot 90 minus A. Okay, so tan A is equal to cot 90 minus A is equal to BC upon AB is equal to BC upon AB. Now AC upon BC. AC upon BC is cosec A, which is equal to sec C or sec 90 minus angle A. Okay. So this is equal to this. Okay. So we can equate now. These are the sine cos 10, then comes the reciprocals. Okay. Then comes the reciprocals. So cosec A will be equal to sec 90 minus A. That will be equal to AC upon BC. And last, no, yes, sec A is left. Sec A is AC upon AB, which is equal to cosec C or cosec 90 minus A. Okay. So let us also mark this AC upon AB. Yeah, we are just seeing the RHS value. So where RHS is equal, so we can easily equate it. No problem. Okay. So it will be equal to sec A will be equal to cosec 90 minus angle A. Sec A will be equal to cosec 90 minus angle A. Okay. cosec 90 minus A, which is equal to AC upon AB, which is equal to AC upon AB. Okay, then the last cot A is AB upon BC, which is equal to tan C or tan 90 minus A, or tan 90 minus A. So cot A is equal to tan 90 minus A. Okay. Because it is also AB upon BC. It is also AB upon BC. So we see that these all are the complementary trigonometric ratios. We can easily see sin A is equal to cos 90 minus A, cos A is equal to sin 90 minus A, tan is equals to cot 90 minus A, cosec A is equals to sec 90 minus A, sec A is equals to cosec 90 minus A, and cot A is equals to tan 90 minus A. Now, for the learning, to be kept in mind, there is a simple remembrance that sin and cos are complementary ratios, then tan and cot and cosec and sec. Okay, so sin and cos are having complementary ratios, tan and cot and cosec and sec. Okay, this is for the remembrance, the concept to be kept in mind. Now we can also check it whether we have these derived the complementary ratios, they are accurate or not. So let us take this sin A is equals to cos 90 minus A. Now let us take A to be equal to 30 degrees. Okay, let us take the A to be equal to 30 degrees. Now here LHS is sin A, so sin 30 should be equal to cos 90 minus 30. Okay, so sin 30 we already know, we have already derived all the values for the trigonometric ratios of some specific angles. So sin 30 is 1 by 2, we already know, and here comes cos 90 minus 30 is 60. So cos 30 is also equal to 1 by 2. So that means the ratios which we have derived over here are absolutely correct. So you can check for all the different ratios. You can substitute some angle and you can check out easily. You can also put 45, cos 45 equals to sin 90 minus 45. So cos 45 is 1 upon root 2. Sin 90 minus 45 will be sin 45. That is also equal to 1 upon under root 2. Okay. So these were the complementary ratios, and these has to be derived in such manner, and these will be useful in the exercise 8.3 of chapter 8 NCERT CBSE. Okay, so thank you. So please subscribe my channel, please share my videos, and if you have any doubt you can ask me in the comment section. Thank you.